The HFW35C is an easy-to-operate, far-field broadband RF meter designed to measure radio frequency and microwave radiation from 2.4 GHz to 6 GHz. The values displayed are the sum of all the sources within the frequency range of the meter. This frequency range covers the radiation emitted by Bluetooth devices, WiMAX, and both the upper and lower Wi-Fi bands. The meter displays the RF power density measurement in microwatts per square meter. Included in the box is the meter with a 9-volt battery installed, the operating manual, a log periodic directional antenna, warranty, and certificate of factory calibration. The HFW35C offers excellent sensitivity down to 0.1 microwatts per square meter and up to 1,999 microwatts per square meter in 2 ranges. When measuring in the 199.9 range, the minimum displayed value is 0.3 to 0.5 microwatts per square meter due to technical limitations, but still maintains a 0.1 microwatt per square meter resolution. The HFW35C has the ability to measure in RMS, a time average signal value, and the peak value that shows the highest output of the signal. This meter also has the option to measure the full signal received, which means both analog and pulse digital sources, or just the pulse digital sources alone. The meter's adjustable audio tone replicates the signal patterns and intensity of measured RF emissions, which aids in source identification and direction. Also included is an auto power off function after 40 minutes to conserve battery life. To attach the antenna, connect it to the antenna socket as shown. The connection should be snug, but be careful not to over-tighten. With the antenna attached, do not sharply bend or twist the antenna cable itself. Shown in this position, the directional antenna is vertically polarized. If you wish to change it to horizontal polarization, loosen this connector slightly, rotate the antenna, then retighten as shown. You can also do the same by simply rotating the meter itself while measuring. The log periodic directional antenna measures in the direction that you are aiming. If you could see its detection pattern, it would look like this, covering both vertical and horizontal polarizations. With this directional pickup pattern, this antenna's best use is to identify the direction of a radiation source. After this source is known, further measurements can be made with the optional omnidirectional UBB2410 antenna, which measures radiation from all directions simultaneously. To begin measuring, set the signal switch to peak mode, set the signal type switch to full, set the signal range to 199.9 microwatts per square meter, and power the unit on. Always use peak and full signal measurement modes when comparing your results to building biology guidelines. Slowly scan an area and follow the direction of the highest field strength. Adjust the volume level of the sound as needed. If the display is showing only a 1 at any point, then switch the range to 1,999 microwatts per square meter and continue scanning. After locating the source and direction of concern, rotate the meter 90 degrees and back and slowly move it around the area for at least 15 seconds to find the highest reading possible. If the display is still showing only a 1 when measuring on the 1,999 scale, you can increase the measurement scale by 100 times with the addition of the available DG20 G10 attenuator. To connect the DG20 G10 attenuator, power off the meter, disconnect the antenna, then attach the attenuator to the meter. And finally, connect the antenna to the attenuator as shown. When the attenuator is properly connected, it will show a green light as shown. With the attenuator attached, the readings on the meter are to be multiplied by 100. For example, if the meter is showing 241, measuring on the 1,999 microwatts per square meter scale, the actual value with the DG20 G10 attached would be 24,100 microwatts per square meter. Once you have determined this highest reading, compare it to the latest building biology guidelines. Currently, SBM 2008 is the most recent building biology standard. A reasonable goal after mitigation would be to have the levels reduced to the slight concern level in microwatts per square meter, as shown. For more detailed information about the HFW35C and examples of common sound sources of microwave radiation, please visit the Safe Living Technologies website at slt.co.